again. In this lecture, we'll be looking at the topic network models and communication protocols. So let's begin.
Hello, welcome back to class. In this session, we'll be looking at network models and communication protocols. So first, let's look at a brief overview of what we'll be discussing here. First, we'll look at client-server model. Then we'll go into the OSI model. We'll also look at the TCP/IP model. After that, we'll discuss a little about encapsulation and decapsulation, after which we'll look at different communication protocols. Lastly, we'll look at the tools for developing internet applications. So let's begin. First, what are network models? A network model reflects a design or architecture to accomplish or achieve communication between two systems. So it helps us to conceptualize or think about how communication can be achieved by different systems. So in literature and in different ways, you hear of network models referred to as network stacks, or sometimes they are called protocol suites. So they mean the same thing. Network models are usually discussed in different layers, and we'll see more of this as we go on. Each layer represents some specific functionality. So having things divided by layers, grouping them into different functionality helps us to better program or design applications that will work. So within the layers of a model, there are usually protocols specified, as I said, to implement specific tasks. Let me illustrate this concept by the use of this diagram and brief illustration. You have systems here, and then you have equipment along the line to achieve the communication of data between different systems. So you have routers, for instance, and there are switches. So, and you have the data you want to go around. So the data with the IP address, MAC address, is transferred from one point to the other using routers to get to the destination. So the data obviously gets across the world, one part of the world to another part of the world, using these communication tools and protocols that we'll be discussing. So first, let's discuss perhaps a very easy way to describe the whole system, which is the client-server model. This model describes or prescribes that there should be a server that provides resources or services that can be accessed by clients in the whole communication system. So if you look at the diagram by the side, you have, for instance, a server. And then you have clients, which could be computers, mobile devices at the other end. So a client makes a request across the internet cloud to the server, and the server responds with the answer to the client's request, getting back the data or the information needed to the client. So this typically depicts the client-server model. So, and different types of servers are available. For instance, the web server, mail servers, file servers are available to provide resources for clients to receive. If we want to design applications for the internet, for instance, a web server is a very useful tool for this. So servers provide resources to client devices such as desktop computers, laptops, tablets, and smartphones. Now let's discuss a very important model or concept that helps us to describe data communication between systems, which is the Open System Interconnect model, popularly known as the OSI model. This was first discovered in the 1980s, and it provides a conceptual way of explaining how data happens in a network. So it's aimed at standardizing network communications. Now, the OSI model explains all the individual functions that are necessary for the internet to work. There are 7 layers in the OSI, And as data travels or traverses the OSI model, each layer adds an additional functionality. So let's discuss the different layers of the OSI quickly. You have layer 1, which is the physical layer. Layer 1 handles transmission of data using bits and streams. So in layer 1, you have devices like the cables that we see here. It allows data to be transmitted using physical bits and streams, the 1 and the 0. So this is the lowest level of the OSI model, physical layer. Now the next layer is the data link layer, which is called layer 2. This layer handles flow and error control on the physical link. For instance, it ensures that the data you have does not overwhelm a system. So there is flow and error control on that physical link. You have devices such as media access devices. Your switches are also in this layer. Your network internet card is a layer 2. All these are layer 2 devices. The third layer is the network layer, and it is responsible for routing and addressing. So if you have IP addresses, routing, routers as we have here, those are layer 3 functionalities. The next layer is the transport layer, which deals with message segmentation, acknowledgement, and whether the mode of communication is reliable or unreliable. So in layer 4, you have two major protocols, the TCP protocol, that's Transmission Control Protocol, and the UDP protocol, that's User Datagram Protocol. Now, TCP is often considered as reliable because it tries to ensure that the data between the two systems is transferred reliably. While UDP is more like a broadcast, it is often considered not very reliable means of data transport. The next layer, layer 5, is called the session layer. This layer handles authentication, the management of sessions, and reconnections. Basically, from layer 4 actually down to layer 7, you don't have devices actually marketed for each layer, as it were. So they are usually grouped together in many instances. We'll see more of that. Layer 5 handles authentication, reconnections, and information such as that. The next layer is the presentation layer, which is layer 6. This layer handles data formatting, encoding, encryption, compression. While the last layer is layer 7, called the application layer. This is the highest level layer in the OSI model, and it usually deals with resource sharing, APIs, and such. So this is in general what the OSI reference model looks like, and the applications, and the devices on each of the layers. Let's discuss a little bit about encapsulation and decapsulation. As the data traverses the OSI model, several components or data information is added to the data as it moves on. So this is called encapsulation. And when it reaches the other end that will be receiving the data, the requisite layer, the data that is added is also removed. That is called decapsulation. Let's illustrate it with this simple video. So you have a data that you want to send. So that data, when it reaches the transport layer, the TCP segment is added to the data. It moves on to the network layer, and another packet, the IP packet, is added. After it moves down to the data link layer, and you have the Ethernet frame added to it. Then it goes down to the physical layer where you have this series of 1 and 0s. Data is transmitted to the physical layer at the other end, and then the encapsulation takes place. At the Ethernet layer, the data link layer, the Ethernet is removed. At the network layer, the IP is removed, and then it moves to the transport layer. The TCP segment is removed, and it moves on to the session presentation layer, and then the data is visible to the receiving party. So this is how the OSI model attempts to describe what happens when a simple data, like making a request for data or information from the sender to the receiver, this is how it moves. Quickly, let's look at another model used to describe data communication in networks, which is the TCP/IP reference model. Again, this tries to simplify the OSI model described earlier to make it a little bit more practical to what we usually do. Now, the TCP/IP model, sometimes called DoD, that's Department of Defense model, was developed actually by the Department of Defense in the US in the 1960s. And TCP stands for Transmission Control Protocol. And of course, IP stands for Internet Protocol. The current version has 5 layers. When it started conceptualizing the data transfer as 4 layers, but it has been modified to 5. So it's similar to the OSI model, but it collapses some of the layers together. For instance, you have the application layer, so you don't have session and presentation. All that is combined in the application layer. You also have the transport layer, the network layer, data link layer, and physical layer. In the earlier model, data link layer and physical layers were combined together, but this has been separated in the latest iteration of the model. So let's think about this activity as we move on. Illustrate the client-server model with a clearly labeled diagram. Explain how data travels or transverses the OSI model. And try and contrast between TCP, IP, and the OSI model. Moving on, let's talk about communication protocols. What are communication protocols? They are simply rules that allows two or more entities of communication systems to transmit information. So software usually use protocols to access data on the internet. So it's nice to know all the different protocols available. For instance, the transmission control protocol, TCP/IP, file transfer protocol, and how they fit with the models that we have described before. In fact, let's quickly look at that now. This is the OSI model with the 7 layers, and this is a 4-layer description of the TCP/IP model. So these are the protocols that work at the different layers of these conceptual models. At the application layer, you have the DNS, DHCP, FTP, SMTP, IMAP, HTTP. It is nice to know all these, what they mean, and their implications for applications that we'll be developing. Then you have, of course, the transport layer where you have TCP and UDP. On the internet layer, you have, as you know, the IPv4 and IPv6. So V means the version, IP version 4 and IP version 6. So every system connected to the internet has a form of IP address, which could be version 4 or version 6. The network access layer, which combines the data link and physical, you have protocols such as Ethernet token ring, frame relay, and ATM. So these are the full functions and definitions of those protocols. For instance, DHCP, called Dynamic Host Configuration Protocol, is used for the assignment of IP addresses, whether version 4 or version 6. You have the DNS, the domain name systems, is used to translate website names to IP addresses. The HTTP or Hypertext Transfer Protocol is used to transfer web pages. Then you have the NBNS, the NetBIOS Name Service, which translates local host names to IP addresses. So there are on and on and on, as we can see on this screen. Now let's talk about tools for internet programming. For you to be able to design an application that can be used by different people in the internet at different places, you need some tools, and that is what we'll be using in this course. One, you need a web server environment. So like we say in the client server model, it helps to serve resources. So now you want to serve websites, so you need a server environment for that. And that server can be, for instance, your local computer, your laptop or desktop. Or you can buy a space on a server in the cloud from a web host company, for instance, Bluehost. We'll look at this in more detail as we proceed. But for this course, a great chunk of what we'll be doing it on our local computer. Then you also need a code editor. So you want to write codes in HTML or in JavaScript or even CSS. Usually a code editor allows you to do that. You can use a code editor called Notepad++ or Visual Code Studio. We will look in detail on these code editors. Then if you want your application to be accessible over the internet, you need to transport it to your the server on your web host. And you will need an FTP client for that file transfer to take place. Design something on your computer and you want it available in the internet, and you already have a server or a space you have acquired. So you need an FTP client to connect to that server, and you can transfer the files that you have developed, the codes that you have written to that server, and it becomes available for everybody. And we'll see more of this as we progress. So a quick look at activity 2. Explain the rationale for communication protocols. Discuss the HTTP, that is Hypertext Transfer Protocol, and then download and install a code editor. Thank you for listening.